Let's design a flat roof installation. First, we name the project. In this case, we'll call it Test Installation. Next, we request information about the solar panel. In addition to the height, width, and panel power, we also need the weight of the panel. This information is necessary to calculate the square weight and point load. Additionally, the system requires the static load, which is the maximum pressure that the solar panel can withstand when attached from the short side, as specified by the manufacturer. This information is needed to ensure that the solar panel can withstand the wind and snow loads at the installation site. Next, we design the actual system. We enter the site address in the search field. Kapalamain Katu, Rihimaki. On the left side, there are icons. We select Draw Panel Group. The drawing is done following the outer limits of the building. In the top right corner, Panel Group 1 appears, which we name Building 1 and set the height to 10 meters. Below, we see that the solar panels cover an area of 737 square meters on the roof. The tilt angle of the racks is 13 degrees. The combined square weight of the solar panels and the mounting system is 10 kilograms per square meter. The point load is 181 kilograms per square meter, which means that when the RAULI flat system is attached to the roof by welding rather than using weight stones, this is the point load that is applied to the roof from the mounting plate. It's possible to change the orientation of the panels. The inner ring is for sensitive adjustments. Next, we choose the system installation method. All panels in one direction or east-west installation. We see that as a single installation, we get 212 solar panels on roof, and as an east-west installation number increases to 320 solar panels. We also note that in a single installation, the square weight is 10 kilograms, and the point load is 181 kilograms. In an east-west installation, the square weight increases by about 50%, the same amount as we get more solar panels. The point load remains the same because the number of mounting plates also increases. Here's an adjustment for the row spacing. We can adjust how much space is left between the panels for maintenance routes. The bigger we grow the route, the fewer solar panels can fit on the roof. We also get to adjust the distance between the solar panels and the edge of the roof. Thanks to this, during the design phase, we drew the area to follow the outer limits of the roof. We see that when the distance is 1.5 meters, the panel field area is 737 meters. But reducing the area to 1 meter, the surface area increases to 792 meters. If the distance is reduced to 0.5 meters, the area is already 850 meters. Next, we plan for Building 2. This roof has clear obstacles that prevent us from installing solar panels on them. We select the Draw Block Area button, which is an area where we cannot install solar panels. After drawing the block area, we can copy it using the right mouse button. Once all block areas are drawn, we can draw the actual area for solar panels, again following the outer limits of the roof. We name the panel group Building 2. Raise the height to 10 meters. Set the distance from the edge to 0.5 meters, and we set the system to be installed as a single. On the third roof, there are clearly a lot of obstacles, and we have to spend more time drawing the block areas. We don't want any solar panels at all in the central area. There are large air-conditioned pipes on the left side, and the upper right is also difficult. Once the block areas are finished, we again draw the panel area following the outer limits of the roof. Building 3 can only fit 125 solar panels, but changing to an east-west installation increases the number of panels to 220. And by bringing the panels closer to the edges of the roof, we can increase the number to 253. Once all 3 fields are ready, we make some fine-tuning. We remove individual panels from the field if there are some small obstacles on the roof. Next, we move downward and notice the message, the maximum static load for the panel is lower than the local snow load, including snow supports, is strongly suggested. The RAULI app gets the wind and snow loads for Kepler-Mankato based on coordinates. The snow load is 2.75 kilonewtons per square meter, which is more than what the solar panel can withstand. Installing separate snow supports is strongly recommended. Let's add these snow supports. The system calculates the components accordingly. Wind plates are not needed. It is possible to add cable channels between each row. The component listing shows the required components for the system. Here is a picture of the mounting plate, which is attached by welding to the roof surface. There are a total of 937 mounting plates. There are 806 snow supports. The quantities of all components can be found in the listing, and most products also have photographs. At the bottom, we see the system's weight. The mounting components weigh 9,100 kilograms, the solar panels 20,960 kilograms, and the total weight is 30,100 kilograms. The system provides a clear PDF summary, which is an excellent document for the customer. We see what kind of system is being planned, the wind and snow loads at the site, as well as the number of panels and the power of the system. Moving on to pages 2 and 3, we see that for Building 1, it is a 344 panel and 146 kilowatt peak system. We see that the system's total weight is 12.8 tons, square weight 15 kilograms, and point load 188 kilograms. Additionally, we see all the components for Building 1. For Building 2, the weight is 8 tons, square weight 10.6 kilograms, and point load 158 kilograms. From page 4, we find Building 3 with a total weight of 9.4 tons, square weight 14.1 kilograms, and point load 183 kilograms. The last page provides a summary. All components together weigh 9.1 tons, solar panels 21 tons, and the total is 30 tons. Here you can see a list of all the components needed to build the planned 3 systems. Let's save the plan we made in the project basket. In Project Basket, we pick up the right project, check the contact information, and send a request for quotation.